Unit 10, Day 7 notes. Today we're going to talk about equations of circles. The equation of a circle with center at hk and a radius r is h minus h quantity squared plus y minus k quantity squared equal to radius squared. If the center... Oh my goodness, what's going on? Hold on. If the center is at the origin, which is 0, 0, and the radius is still r, the equation can be simplified to simply say x squared plus y squared equals r squared. So now we're going to practice graphing a couple of circles. Notice on your notes there are 4 circles, and on your packet, sorry. But I'm only going to demonstrate 2 of them. That means I have all the confidence in the world that you can do the remaining 2 on your own. So, in order to identify the center and radius, it's probably best to write the generic form of the equation directly underneath. The generic form is x minus h squared plus y minus k squared equals radius squared. With that being the case, you can see what is in h and k in r's position. So in h's position, because the center is hk, so that's why h and k are important. So h is 4 and k is 3. The minus sign is intended to be there, if you remember. That's why I wrote the generic form of the equation down there. So that means you just need to simply just take the number out. Another way to look at it is when you take the number out, you change the sign. So if it's a negative 4, you're going to take it outside the parentheses and make it a positive 4. If it's a positive 4, when you take it out of the parentheses, you make it a negative 4. So whichever works best that makes you or helps you understand it. So that means the radius is 5. Because at the end it's supposed to be radius squared, and it says 5 squared, so that means radius and 5 are in the same position. So now I would start by plotting the center, 4, 3, go over 4 to the right and 3 up, and I would label it C for center, and then use the radius to find other points on your circle. So in all directions you can go 5 and there will be another point. So if I go 5 to the right, 1, 2, 3, 4, 5, there would be a point here. I can go 5 upwards, 1, 2, 3, 4, 5, there's a point there. 5 to the right, left, I would end up here, and 5 downwards, I would end up right here. And then connect it with a circle as best as you possibly can. Oops, I totally missed that last dot, but that's your circle. And you might want to draw your radius on there as well. Now for the next question. Again, it helps to write the generic form underneath. So x minus h squared plus y minus k squared equals r squared. So if you notice, my x's there's nothing being taken away from the x's or being added to the x's. It's just simply x squared. So whenever that is the case, that means h is 0. Now K is 2. So the center is at 0, 2. Now remember, the last number is your radius squared. So if the radius squared is 49, you take the square root, which means the radius is 7. So the radius is 7. So let's plot our center. 0, 2 is on the y-axis, 2 spaces up. That's your center. And now again, we're going to use the radius to find at least 4 other points on our circle. So 7 to the left, to the right, up, and down. 2, 4, 6, 7 would be here. 2, 1, 2, 3, 4, 5, 6, 7 would be there. 1, 2, 3, 4, 5, 6, 7. This is 2, so 5 more. 1, 2, 3, 4, 5. And again, connect it as curved as you possibly can. It doesn't have to be perfect. Mine aren't perfect. Mine tend to look more like diamonds. And that's how you graph a circle. This concludes your notes for today.